All right. We are going live.
Great.
Hi, everyone. Welcome to Globant's webinar. We'll get started in a few minutes, just giving people some time to get logged in. Thanks. Hi, all. We'll just give a few more minutes for people to get connected. We're glad you're all here. Thanks for coming. Well, hi, everybody, and welcome to Globant's webinar on virtual reality and the future of workplace collaboration. We're glad to have you all with us. My name is Anna. I'm communications analyst and AR manager here at Globant. I'll be your host today. Some housekeeping issues to keep in mind. If you do have questions for the speakers at any time, please feel free to put the questions in the Q&A chat here in Zoom. We'll be sure to get to as many of them as possible. Also, I see a question already. Could you send me the video when finished? You betcha. If you are here, you will be receiving the video after the fact. So don't worry about that. We've got that recording set up for you. So yeah, without further ado, I'd like to introduce our speakers for today. So we're really glad to have with us today Matias Rodriguez, our Vice President of Technology in the gaming studio at Globant. He's based in San Francisco and has more than 15 years of experience helping to create products, many of those including AAA video games. Welcome, Matias.
Thank you.
And we also have with us today Ben Humberston, software engineer at Facebook Reality Labs. He's been developing and researching for about 10 years now, and he previously worked at Autodesk and EA, among other organizations. Welcome, Ben.
Thanks, Anna. Glad to be here.
Cool. So Matias, I think it's up to you. Do you want to get started?
Definitely. So thank you very much, everybody, for joining. So a lot has changed since we last spoke publicly about VR. Our last webinar about the topic was a couple of years ago. Since then, we tested many devices. We created several proof of concept. We work on different mixed reality projects for a variety of different industries, from entertainment to finance and healthcare. So nowadays, we are actually in a more mature environment. There are several devices on the market available on different form factors, from low fidelity and more cheap options into more tether and high definition room scale VR experiences. So the amount of user is growing, as we can see here. Additionally, not only hardcore gamers are using the platform. So even if we cannot say that VR is actually mainstream, it's definitely growing into adoption overall. So as we can see here, mainly driving by gaming and entertainment experiences, the investment in general is growing, and particularly on different other industries like healthcare, retail, and other areas like manufacturing are continuing their adoptions. They were probably more of the early adopters, especially because access to dev kits is more affordable, and they have a high risk environment that they need to actually deal with. So on our side, after experimenting and working on different projects, we learned to create these worlds. We play around suspension of disbelief. We tested with haptic feedbacks. We added choices and gameplay mechanics that allowed us to move and match external characteristics, as well as perform different activities on these worlds, right? And after all, we came to a conclusion and started to take VR more as an emotion or empathy platform. So we discovered that based on the needs, we as creators have the ability to set up a scene, and we can essentially trigger the emotions that we want. So as a result, over time, we learned some qualities about VR, and probably when Ben shows some of his examples, you will experiment some of these, especially if you test it on VR. But the first one is that it's immediate. Once you put the headset, you are in the world. There's no escaping. The second one is overwhelming. We all felt the sensation when we experiment the VR device and when we feel the rush on a roller coaster or something like that. The third one is unavoidable. So as creators, we control the full field of view. So we control everything you see, essentially. And there's no escape. Obviously, you can take off the helmet at any moment, but essentially there's no escape once you are in the world. And finally, because of all these items combined, we actually have a kind of an empathy platform, kind of a full universe we can control. So the storytellings and the emotions we can trigger are essentially endless. And that means that technology nowadays allow us to capture and mimic realities, like we can see here. Using 360 cameras, we can record sphere scenes, allowing us to put you in different situations so you can make choices. But at the same time, it allows us to create new worlds and have full control of the scenario, the emotions, and the scripts that are related to that. So in order to execute these projects and create these experiences, we need basically on the corporate world, a new breed of profiles and capabilities that are required to create these worlds and being able to manipulate. Starting from the creative and storytelling, script definitions, character creation, bios, situational descriptions. You basically need to create the basics of the stories. We also need concept art to iterate and refine. We need 3D art, both on modeling as well as texturing or painting. And additionally to these stations, we need sound effects as well as soundtracks for some epic moments. From the technical point of view, we need to create this experience on game engines that already provide the game mechanics and the foundations we need and the tools we need to streamline the creation process. And that requires some background in gaming or interactive 3D development. Finally, gameplay mechanics and different techniques that are present on video games and simulation and different media needs to be integrated in order for these worlds to come alive. So as we saw at the beginning, VR adoption is expanding beyond gaming. At workplace, is creating new ways to collaborate from the design and process and validation of high risk or high cost industries like car manufacture to enabling initiatives like digital twins on, again, manufacture and construction industry. Additionally, as learning platform, it's solidifying its presence as a preferred method for onboarding new employees, for having situational training, with some proven success cases we can explore shortly. Finally, as communication platform or telepresence, VR and its capabilities, as Ben will show you on the next part, it's creating a whole new way to interact with people all over the world. And if we really think about it, it could revolutionize the very fabric of how cities and how offices are built to, how offices are made to connect employees and foster innovation. So as a couple of examples, like we see here, Airbus is implementing room scale VR to enhance aircraft maintenance and training over their planes. And as they published on the paper on February 2019, it's helping on the daily trainings, reducing time and cost. Even if you have a upfront content creation, fixed cost, the efficiencies on the delivery method, as well as the behavior change and the impact that can have on trainees could justify the initiative. So we can say that there is some optimizations in terms of cost on the long term. For the second example, we also point out Intel that it's already implementing VR training. They publish a paper where they showcase how Intel deploy VR corporate training, a solution across the whole corporation with a high return of investment. And they highlight something that probably we all already know, that humans learns best by doing, and essentially having these platforms and this world in a way that we can manage and we can control, it allows us to create the environments where these people can learn. And as we see here, the adoption was so big that pretty much all of the employees that took the train has essentially asked for more VR content to be delivered. Also, they projected that after 5 years, they essentially could reach 300% in terms of returns of investment. So again, we see that many companies are starting to see VR as a platform to start deploying different processes and try to optimize, automate, and make more efficient, especially on, again, communication, collaboration, and the learning point of view. So now we will be switching to Ben, who will be showing us some very interesting work that he's doing in Facebook.
Great. Thanks a lot, Matthias. Let me share my screen just one moment here. So what Matthias talked about a lot is kind of the current state of VR. And what I'd like to do is talk about the future of VR. So I'm at Facebook Reality Labs. I'm a software engineer there. So what we do there here at Facebook Reality Labs, we're trying to create the future of virtual and augmented reality, also known as VR and AR. Kind of looking out beyond the current product cycles, looking out 5, 10, or more years and saying, what is really possible with this technology? So when most folks think of VR today, as kind of Matthias pointed out, a lot of these are gaming applications or virtual travel, so you can feel like you're going to the Grand Canyon or the Eiffel Tower. But what I'd like to talk about today is particularly a different direction that could change the future of work when it comes to people. So to kind of take a very simple question, why do we travel for work? It's not going to be a kind of simple answer for any single industry. Oil rig engineers, teachers, stock traders, these are all going to travel for very different reasons. But if we look at knowledge workers specifically, people who create value by collaborating and creating with other people, there's often a very particular reason for that. It doesn't seem necessary because, so take myself, I work at Facebook's office in Pittsburgh. I collaborate a lot with people in California and Seattle, and I can do this using email, workplace chat, which is our internal messaging system, or other things like that. And yet I still end up traveling to the Bay Area or in California or Seattle a few times every year. And the real question is, why do we do this still? Given the internet, why do we do this? If you work in a remote location or have a distributed team, there's a very obvious answer to this, because there's simply no substitute for that face-to-face interaction you get when you travel. And companies know this, which is why in 2018, they spent over $300 billion on travel-related expenses, which includes airplane travel, hotels, food expenses, so on. And this cost over 400 million trips for people doing this. So there's real value in this. This is not just wasteful resource spending so people can travel around the world. Even though we have the internet to facilitate communication remotely, there's just our highest value interactions come from face-to-face meetings. Of course, then you might ask, well, what about video conferencing, just like we're doing now? So you can have people on their computer with 2D videos from their laptop screen. What's wrong with that? And we have VC systems within Facebook. We actually have really great infrastructure so that I can feel like I can meet with people in the other offices within Facebook very easily. We have great software and hardware infrastructure for this, and yet I'm still traveling. And the reason for this is because VC, or video conferencing, is an imperfect medium despite all the advances. So let's think about what a typical VC meeting looks like compared to an in-person meeting. So what you get with an in-person meeting, especially with a small group, is something that's more dynamic, more productive, more engaging, and ideally more fun. Although I understand not every meeting is going to be as fun as you'd like, but this is kind of the potential. Things like Zoom or Skype or this, they've improved a lot, but they're still not at the gold standard for these high bandwidth productive communications from these in-person meetings. And this is, as I know, kind of particularly true when you have small group meetings. So not just one-on-one, but maybe 3 to 6 people having a meeting over with each other. When you do this in VC, what you end up with is more and more tiles starting to fill up your screen and jostling for screen space. When you have more people in a small group meeting, you add more energy to the room, you add more dynamics, more perspectives, and you end up with generally a better experience. So given these kind of 2 observations, I want to make what I hope are kind of 2 uncontroversial statements. The first is that video conferencing meetings with 2D video feeds of people, as good as they are, they're never going to replace in-person interactions. And the second is that we can do better than video conferencing meetings by focusing on recreating in-person interactions better. So that kind of leads us into what we're doing at Facebook Rally Labs, our Pittsburgh office specifically. Our mission is to find the key technologies that are going to make interacting across distances indistinguishable from real life. It's not going to come as a surprise at all that we see virtual and augmented reality as a big part of that, because they create these immersive spaces and have all the fine qualities that Matthias was talking about. But still, there's this open challenge today of how you actually want to represent people in those virtual spaces. So we're not the only group at Facebook looking into this. The Oculus product group over the past few years has developed really wonderful avatars with lots of options for customization and personalization. This includes hand tracking. They have what they call kind of lively gaze tracking, even though we don't have any sort of gaze tracking in the Rift headset. We get varied expressions and lip syncing and more. But obviously, we still think there's room for improvement. These still feel a lot like video game avatars as opposed to something you'd want to have in a real meeting. So in Pittsburgh, after a few years of iteration, we think our vision for a rich, authentic representation for people in VR is really starting to crystallize around a particular key technology. And what we call that is codec avatars. We call them, they allow you to communicate in real time with photorealistic appearances. So the name codec is an allusion to how we actually represent these avatars in VR. When you're using them for a conversation, your social signals are encoded on the transmitter's end. They're sent over the internet, and then on the remote side, they're decoded for the rendering inside the receiver's VR headset. So that data that we send over the internet is called codec data, which is a combination of encoder, decoder. You can actually think of it a lot like something that's analogous to audio and video codec data that you send over the network for a traditional video conferencing meeting. I can actually talk more about how they work during the Q&A if we'd like, but usually the best introduction for these is a short demo. So let's give that a shot. Before we do so, though, a very quick disclaimer. Everything you see here is a research prototype, not an actual product. This is very much cutting edge research. It's not a solution that you can deploy widely today. It's going to be something that we hope to deploy in the future. But just don't, if the question is, when will this be available? It's not for some time yet. So with that out of the way, let's actually see how they can work in practice. So here we have two folks from our lab using VR headsets, and they're going to talk with their codec avatars. Hopefully you can hear the audio. If not, I'll just give a quick summary afterwards.
So I was telling you that I believe in ghosts, and you don't because you believe in science.
Yeah.
So I think I watched too many ghost stories. I used to come home from school and watch Are You Afraid of the Dark? Every day. Did you ever watch that show?
Yeah, I watched it a couple times. I think I read some of the books too.
They had books?
Wasn't it? No,
Is that
I'm thinking of
Goosebumps?
Goosebumps.
Yeah.
I'm thinking of Goosebumps.
Did you watch that movie? They made the Goosebumps movie with what's his name a couple years ago? That was weird.
I didn't
So,
see it.
so what you're seeing here are two people in separate spaces wearing VR headsets. And with those VR headsets, they can talk to each other just like they were in a single shared space, despite being apart. In this case, they're not particularly far apart. We just have them in separate rooms in the lab, but the same principle would apply for talking over a network. So those sensors are not just regular VR headsets. They include enough inputs to allow us to actually track what their faces are doing in real time. Let me show just one more additional demo.
So
here we go. So here we can see myself and an external participant talking using these similar headsets. They're slightly different ones. We don't have as big of a mouth guard there. I'll just play this through so you can see one more demonstration of how codec avatars work.
What kind of yoga do you do?
I do hot yoga. I love hot
knew it.
yoga.
Oh my gosh. I've tried it a few times. Hot yoga, I just want to, oh my gosh. I sweat so much. I melt in there.
I love it.
But like the session ends and like I just need like a gallon of water. I just walk right out of the room and yeah.
Exactly.
So what we see there is myself and the participant talking with these avatars. We can communicate with kind of this clarity that you really don't get with typical VC meetings. Sorry, I think something went wrong here. Just give me a moment to make sure that I'm still transmitting. Sorry, one moment, please. Okay, great. I think I'm back online here. I believe so. Yep, great. So creating these avatars is not particularly easy. In order to create these, we have a high fidelity capture system down in Pittsburgh that captures hundreds of images per second. So these systems are actually producing terabytes of data for every capture session. But using machine learning, we can actually reduce that into something we're able to run in real time. And so to give you an idea of what this looks like, I'm going to show you a side-by-side here of what our original capture is and what the avatar itself looks like. So on the right is the avatar, and there's this line sliding back and forth showing the original capture on the left side. So if you look closely, you will see some differences between the original capture and the avatar we recreate, but we're starting to close in on a perfect recreation of the person's appearance. So using these capture systems, we've actually produced hundreds of avatars for internal and research participants. And even so, though, we're limited by the amount we can scale at our current research stage, including part of that limitation is the amount of data we need to capture for these high fidelity captures. Our dream is really that one day anybody can really create their avatar just by snapping a few selfies using their smartphone or something to this effect. But for the time being, this very much remains in the research stage. Once we have that avatar though, it's not enough. That's just one side of the coin. It's not really useful until you can match what you are doing in real time with what that avatar should be doing on the receiver side. So to that end, we developed a technique for animating these avatars using cameras mounted on a prototype VR headset. And you can see the view that these prototypes get from the images here on the right in gray. We presented this in the paper VR Facial Animation by Multi-View Image Translation at this year's SIGGRAPH, and I definitely recommend looking that paper up for more details. So now, something you probably thought to yourself while watching these videos, I promised you interactions indistinguishable from real life. But what I've given you so far are just faces floating in a void. You might be asking, where are their bodies? Where are their hands? Where's the rest of the world? How are they not just communicating, but collaborating in these spaces? And the answer to that is that most of our work so far in the lab has focused on high fidelity faces for VR. It's traditionally a very difficult area for computer graphics. If you've ever heard of the uncanny valley, a lot of what we do is we try to cross this uncanny valley from cartoonish representations to photorealistic. But getting it right is really valuable because there's so much social information that we broadcast through our facial expressions alone. Going forward though, we're also really exploring how to move beyond faces to the rest of the factors that make in-person meetings so powerful. So this includes things like full bodies, full environmental reconstruction, on the face itself, we want better eye contact between our avatars. We'd like to see better hair reconstruction, better expression matching. And also we'd like to look into collaboration prototypes to see how people are going to be using these avatars to get real work done. But so far though, we've just started to crack these problems. And there's a lot more work to be done here. If you're interested in learning more about how exactly these avatars work, I recommend seeing the Reality Labs lectures on photorealistic telepresence from our lab's director, Yasser Sheikh from University of Washington. He goes into a lot more technical detail about how these work and where we think they're going to be going into the future. So I'll conclude by noting that these are really early days and the research is ongoing. But even so, we think that realistic telepresence and VR and AR, it's going to completely change how we think about travel and work. So right now, we travel for work because meeting and collaboration in person is so unbelievably powerful. But travel isn't always possible, or it may be too expensive, or it may be impractical. So what we'd want is to benefit from those in-person interactions without leaving our office or home. And another factor here is that economic opportunity is often concentrated in specific cities or areas today. But if we have this realistic telepresence, it can be an open invitation for everybody to contribute to that economic opportunity, no matter which city, state, or country you happen to live in. Someday, the hope is that what we can do is we can decouple where we work from where we choose to live. And that's going to let people make connections across the world and collaborate face-to-face with anybody, anywhere. It's not a small dream, but our lab is really dedicated to making this happen. So we're excited to see where it goes in the future. And with that, I'll conclude and I look forward to your questions. Thanks a lot.
Thanks so much. Thanks, Ben. Thanks, Matthias.
Yep. Yeah, no problem.
Material for conversation here. So now I'd love to turn it over for a time of Q&A. And I do have quite a few questions to get started with. So let's get to it. Let's see here. So one of the questions we got, considering all that you've talked about, how, or I guess the question is, what are the biggest challenges for the AR industry as far as overtaking devices and technology that we already make use of on the daily? Challenges like design or hardware limitations, or even sociocultural limitations? What are some of the biggest challenges?
So Matthias can kind of give his 2 cents on this. From my side over at Facebook, who Oculus is one of the VR headsets that we create. And while they're a lot smaller and more manageable today, you don't find everybody putting on VR headsets en masse right now. And one of the reasons for that is there's kind of twofold. One is the ergonomics, while a lot better than they were 10 years ago, are still not quite there. They have something of a larger form factor that it's had some bulk, and they're good for wearing for maybe an hour or two. Beyond that, the comfort can go down. The other factor is the display fidelity. Something that's very interesting is that with 2D displays, what we have are screens that are incredibly optimized for transmitting information between people. And so when we go to VR, even though you might have a high resolution display panel in there, that resolution is stretched across a much larger field of view. And so when you do that, you end up with effectively lower resolution, and it looks something like, closer to a circa 2000 video game than like the HD screens you get today. So if these sort of VR headsets came out in the early 90s, they would, I'm sure, see incredible instant adoption, because the alternatives at that time were simply not very good. Whereas the alternatives you have today with iPhones and high resolution laptop screens, it's very hard to compete with those informational devices. So I think improving resolution and improving ergonomics are going to be very key to in seeing more adoption in the VR space.
Cool.
Yeah, definitely. And just to complement on that, on the social aspect, the fact that you are kind of isolated make it kind of a weird from the social point of view. So obviously adoption of different other devices that overlays mixed reality like AR seems to be more suitable for mass adoption. But definitely there are some use cases that we saw that the SERVs and VR can help and fix for sure.
Mm-hmm.
Very cool. Are we ready for another question?
Sure, sounds great.
Is there some kind of volumetric capture that takes place also in the planning and development of the avatars in current hardware?
So for codec avatars specifically, yeah. So when we create these avatars, it depends on what you mean by volumetric specifically. With these avatars, it's actually hard to get this across in 2D because of this reason, but these avatars are fully 3D. So we have an array of cameras that surround a person, and with those cameras, using computer vision and machine learning techniques, you can actually reconstruct the full 3D representation of that person. It's not, even though your source imagery is a 2D camera image, you do something a lot like what we do with our eyes when we see something, we see it in 2D, but we reconstruct a 3D scene in our brain. We have machine learning techniques that reconstruct the full 3D person from that. Some of our, it depends on our representation. We're experimenting with new ideas. Our traditional avatars use a geometry and texture in order to represent them that are actually in some sense flat. So they're a little bit more like a video game character, but we have also experimented with full volumetric representations that are actually a lot better at representing very fine voluminous structures like hair. This is one thing I didn't actually point out. Our representation today, it's great for faces, not so great if you have very long flowing hair. So we're trying a lot of new ways to do that.
Gotcha. Very cool. Another question to throw to both of you guys. How can this technology be used for online education? Have you looked into that?
As far as, yeah, sorry, I can go and then you can complement. But as far as VR, for sure, there's a lot of learning applications. Depending on, again, the definition of online, could be tricky to stream content, but definitely VR is being used for learning applications all over the world. As for avatars, I will let Ben to complement on that.
We haven't looked too much specifically into learning applications itself. I mean, obviously, realistic avatars are going to be useful for work, learning, home, things like that. There is, I know, work within VR. I mean, I think actually Matthias noted it briefly that a lot of our learning today is based on the idea of you read something in a book and you commit it to memory, whereas humans are, of course, much better at learning when they're learning by doing. So going out and actually trying something. So I'm not sure. VR is used for some industrial training applications today. As I think Matthias pointed out, this does show pretty good results. We'll have to see when this becomes more widespread. In terms of like primary education, things like that, I think it'll be useful for learning for the same reason it'll be useful for work, in that if you can allow a teacher to instruct a student from remotely without actually needing to be in the same room as them, that reduces the cost of actually having connections between those people. But again, we haven't actually tried education prototypes within our lab.
Now, something to notice there, because of the deep characteristic of what Ben showed, learning across soft skills and empathy, all of that could be reconstructed through, again, captures. And what Ben showed in terms of technology could be applied to essentially position people in certain conversations or in certain scenarios where facial expressions and all of that language, body language, is important for either learning or reacting.
Right. I mean, I highly recommend anybody who can try VR, because it's very difficult to explain with 2D media, but you have so much more of a sense of presence with another person and kind of being there, that it kind of taps into subconscious systems in a way that 2D media really doesn't. And particularly for learning, that could possibly help a lot with retention, things like that, I would imagine. But I do not know, details offhand.
Yeah, that's cool. And it ties into the next question. A couple people are asking about the experience of a VR headset, in terms of, if we're thinking in the workplace and we're talking to a boss or a manager, what's the experience like to talk to your boss, which already could be intimidating, through VR instead of in presence? Or do you have any sort of feel for the feedback that you've received while testing these devices?
So, I mean, typically the feedback we get when people try it out is like, wow, it feels like I'm talking right to you, which is great, because that's exactly what you're looking for. I think maybe what the question is getting at is that having that presence with another person is you get both the benefits as well as possible drawbacks. So if people feel intimidated or things like this, that intimidation, if you feel that in person, it can translate directly into what you feel in VR. And this is actually an issue in VR, because you've gone from, in terms of the possibility for malicious actors, you've gone from people who can make bad comments to people who can, are really there in your space. And so this is something we do think about a lot within Facebook and Oculus. So basically, how do we bring people together in these very rich virtual spaces and get the benefits of empathy and feeling, collaborating together and sharing a space without the downsides of intimidation or harassment or things like that? There's no single answer to this. The beauty of virtual space is that, unlike real life, you can actually exert more control over your virtual space than you can over a physical space often, because these virtual spaces can be personalized to you. That said, I'm not sure whether or not you'd want to, zap your boss out of existence in a virtual space, but you can mediate these interactions better than you perhaps could if you were called into their office. I'll actually make
or you can change your voice into something more funny, so maybe that can help on the staging. Just to complement on the question, as Ben mentioned, you get the benefits and the drawbacks. I think that what is important is that these connections can help, and this technology can help to test the different scenarios. So you can even play around with scenarios where your boss is being more mad at you than some others.
Right. And actually, I'll share one more thing which has been interesting for me, I found. A lot of our prototypes, we actually, your height in VR is actually something which is very interesting. So we can represent your real height in the real world as best we're able. But actually, a lot of our prototypes, we end up with people, just for technical simplicity, we'll actually end up with people at about the same eye level. And what's very interesting is that while most of your characteristics will come through VR, when we put everybody at the same eye level, this kind of takes away any bias you might have. Well, not entirely. This limits the bias you might have based on, well, this person's taller, this person's short, and that's going to influence how I see them. So this is really more of a byproduct than like an explicit intention, but this is kind of the idea, like the very subtle things you can change in VR. So if everyone is the same height, you remove that sort of biasing factor. Whether or not that's what we'd like to do from a product decision, this remains to be seen. But it is kind of an interesting informal experiment to find that people perceive you differently when you all have the same height in VR versus having, you know, somebody who's very tall and intimidating.
Huh, fascinating point there. Okay, another question here. Talking about the security side of things, is there concern and or research into identity protection as part of the research, or what kind of challenges do you anticipate, you know, in regards to identity theft or how to prevent that?
Right. So this is something of which we are keenly aware, and we think about it a lot. We are investigating solutions for this. It is a tough problem, and I mean, I can't say too much more at this point other than just we are well aware that feeling safe in this, in the world of these avatars in these virtual spaces is on the top of mind for everybody. So what we're doing is we are kind of looking into solutions for actually securing avatars, securing interactions to prevent malicious use, things like that. It is a broad, there are many possible ways that things can go wrong, and we're trying to take a broad view and look at all of them. At this point, because it is still very much in the research stage, I would say stay tuned. As we kind of start thinking about products, we'll be able to share more there.
Very cool. This perhaps a question for both of you. What kind of internet connectivity do you need for virtual reality technology to make sense and be sustainable?
I'll answer that from what it means for codec avatars specifically, and related to some of the Oculus avatars. So the interesting thing about these avatars, and this will become more apparent if you kind of know the details of the technology. The codec avatars that we represent, the model itself is not a small file. So there's kind of this upfront cost of saying, if I'd like to, call you, then I will, you'll load your avatar onto my computer. But beyond that, the actual incremental cost to communicate using these avatars is lower than what you get with video conferencing. And the reason for this is because with video conferencing, especially as we get higher resolution cameras and higher resolution screens, you need to send very large data. It's not small. You're sending, like a 4K image every, 30 times a second, things like this. Even with high quality video encoders, that's going to require a lot of bandwidth, which is why, you need a nice broad, high fidelity broadband connection for Netflix or things like that. With codec avatars, we're not sending the entire image of what you're doing at 30 times a second. Instead, what we're going to be sending is essentially a very compressed code which represents your expression right now. So that code, because it doesn't need to capture every part of what you're seeing in the scene. So if there's, there was a mountain behind me or this or that and the other thing, these are all irrelevant details. Whereas what we'd like to actually transmit is your expression precisely, because that's the important information. And turns out if you have the right compression scheme for that, that can be lower cost in terms of network bandwidth than what you have with video conferencing. Once again, everything I'll say is always qualified with this is research, so we can't give exact numbers, but our hope is that we can produce these avatars without kind of saturating people's bandwidth the way you do with high quality video. The one thing that is very important for these, and Matthias can talk more about it if you'd like, is keeping the latency of these interactions very low is critical. This is something that we've kind of accepted with the advent of cell phones and things of this nature. We have a lot of extra latency in our communications relative to what we'd have otherwise, maybe on the order of 100 or 200 milliseconds, which seems like a very short period of time. But if you try, if you talk to somebody on the phone with 200 milliseconds of latency versus, 10 milliseconds, it feels so much more like you're present with that person, and you don't kind of have this start-stop stuttering when you're talking to them. So that's going to be what's critical, actually. Is lower latency is more critical than high bandwidth.
Yeah, exactly. As Ben mentioned, a lot of these interactions are actually real time. So there's no equivalence to streaming video or complete scenarios. As Ben explained, the amount of handshake and the exchange of messaging is not the big deal. Now, in terms of latency, again, we all notice, especially probably the ones that are older, like me, when we talk with people all over on the older phones, and we spoke with remote people, like you talk and you get a delay. That's actually very uncomfortable on just audio. Now imagine on like facial expressions, like Ben was showing. So it is very important to keep a very high pace. So high performance and low latency on the experience is very important. Even more considering that VR already requires high latency to avoid motion sickness, which I saw that there were some questions also.
Yeah, and another question, perhaps to tag off of that one, a lot of people are asking about the experience of body language, the importance of body language in a conversation, not just the facial, but also the body cues that we give when we're having a conversation. How are those experiences in VR?
I can talk to that, as I kind of alluded to earlier. Without your hands, your face carries a lot of information, but surprisingly, your hands carry a lot as well. So something we've noticed is when we do some of these demonstrations with avatars who are just faces and we don't show people's hands, is people will still express with their hands on each side, and then they'll after about 30 seconds or so they'll say, oh, I realize now you don't actually see this, so you're not getting any of this. So we've received a lot of informal feedback that kind of expressing with your hands is kind of another component that we're missing. The Oculus products actually do have, using the touch controllers, assuming you're willing to put up with holding a plastic controller, we do have hand tracking and kind of some very moderate fidelity hand, being able to gesticulate with your hands. This is another area our lab is looking into in terms of, okay, well, great. How do we say, well, how can we track your hands for real? And how can we recreate what your hand is doing very precisely? It's something of a tricky research issue, just because hands are, if you've never noticed before, very highly articulated. You get a lot of occlusions between them. So just from a research and technical side, capturing your hands is, I wouldn't say more difficult than capturing your facial expressions, but it's not easy. It has its own set of challenges in order to recreate this in VR. But we do understand it's absolutely critical, because people, do have body language. Your face is not the only thing they're using to communicate.
Yeah, just to complement on that, I think that Ben and the team at Facebook Reality Labs is focusing on one of the key elements, and Ben mentioned about the uncanny valley, and it's something like digital humans, and even for techniques like de-aging, which we can see on most Marvel or Star Wars movies, we can still feel and notice the characters that has been or de-aging or reconstructed because they were not available anymore. So I think that they are tackling one of the key challenges. Hands and some others, it's generally another challenge to tackle. So body expressions, it's like a different kind of problem that needs to be solved. So I think that that's why the Facebook Reality Labs team is focusing on reconstructing faces, and that's actually one of the most challenging as well, as Ben mentioned. Then as for the others, there are kind of beacon and technology available, still very bulky and not very consumer facing, but it's essentially a problem like animations and how people move. Once you get a decent capture and good reference points, it's something that you can actually reconstruct, whether facial expressions, is especially the small ones and the details that, as Ben was showing, are the most challenging to reflect on a conversation.
Gotcha. Yeah, that makes sense. As another question that's been launched by a couple people, I get that this is a webinar where we're talking about workplace applications, But are there other industries that you think this technology after the workplace might easily translate into an application for those industries? Somebody suggested perhaps travel. There were a couple other suggestions. I wonder if you can speculate to where you'd like to see this technology go next.
Yeah, so I'm thinking mostly about workplace here, just because as somebody who works in what might be considered a remote office of Facebook, we keenly feel the issues of using VC and collaborating remotely with our West Coast friends. In terms of other industries, I mean, while honestly, most of what we do is wherever people are communicating and need to communicate with high quality, that's where this technology can be applicable. So if in the case of travel, what VR is very good at today is capturing the appearance of remote spaces, perhaps getting a 360 video of that space, and you can kind of experience it from afar. But as anybody, when you travel, that's not really what you feel. You don't just go there and go through this, linear presentation of the content and leave. You go, you interact with people that you find there, you dine, you shop, things like this. And these are all interactions which involve people. So in terms of travel, yes, absolutely. Something like this could be useful for, if you have virtual travel. So if I wanted to go have a kind of pseudo vacation to France and meet the locals there, this will allow me to connect with real people there, not just go and look at the sites and in this strange, space devoid of people. Beyond the workplace isn't a particular industry, but obviously something like this could be useful for connecting at home. So my mom is actually down in Florida now, and it's wonderful to talk to her. But what I'd really love is if I could have, a conversation with her just like I'm right there in the same room. So the same reasons that this is effective for work conversations could also make it very useful for general social events.
Yeah, additionally, adding high fidelity to any of the other many applications we saw, like manufacturing, high risk, aerospace, training, even entertainment. We saw, again, we were talking previously about some Disney movies. So anything that you can imagine will require, as Ben mentioned, interactions. So it's so basic that could affect basically any workspace scenario. Then for particular industries, obviously entertainment and travel, and then manufacture, high risk, and construction could be very applicable. Definitely medicine, healthcare, recovery. Some people were asking about rehab. So again, VR has been used on many of those industries. What traditionally has been happening is that as the pipeline to create content becomes better, more accessible, and more cheap, and at the same time more high fidelity, it becomes obviously more critical to start updating those. So what Ben showed us could essentially enhance a lot of the experience that are already happening around the world. And as we spoke especially about training of some soft skills like leadership skills, situational, put people in some tricky situations so we can see how they reply. And even I can, because I have the gaming background, I always have some sort of like those analogies. But if somebody play a game called LA Noire, it's a game about a detective, and that's about expressions. So again, it's very focused on seeing what people tell you and figuring that out if people is lying to you. So a lot of what Ben show can actually make communications more transparent, even again, going from a video conference into more on a telepresence approach.
And I'll make one more note about travel specifically. Something we will occasionally hear when showing folks is they'll say, well, does this mean that I won't ever have to travel again? And I think that's the wrong conclusion to draw from this. What this technology does is it provides something that complements travel. So, if I were able to go and see the Louvre without ever leaving my home, that would be great, but there's still a chance I might go and do so. I still might choose to, get on a plane, travel across the Atlantic and see it. And the reason for this is because while these are going to be high fidelity representations, they're not going to be total replacements for actually going and seeing something. I forget the exact quote, but there's something from Ready Player One or relay books like this that reality isn't great, but it's the only place to get a good meal or something like this. So these experiences are high fidelity. They are closing in on kind of the real experience. But as yet, I would definitely see them as a complement to, actual experiences like travel. So they can get people interested in travel. They can kind of whet their appetite. They can give the simulation, but it's not going to be something that will absolutely replace it just yet.
Sure. And we did see a question to that effect. Whether you guys have heard about anyone investigating adding other senses like smell or taste into virtual reality, whether anybody's looking at that yet.
I know there are a number of, I believe I've seen some Kickstarters in terms of adding smell to VR, taste, things like that. These are tricky areas. I think a lot of what you see in terms of information exchange today is audio and video, because these are things that are kind of, without getting too technical, they're energy transfer. So you can recreate it by pushing photons and audio waves. Whereas smell and scent and kind of haptic touch, these are things which require, in the case of smell and taste, kind of chemical components to them, which are much, much, much messier and trickier to deal with. I've seen various incarnations of this tech over the years, but it's overall a difficult thing to pull off.
Yeah, definitely. And as Ben mentioned previously, traditionally the approach was to try to tackle the senses that provide the most perception of reality. Obviously, smells and taste are very essential in terms of real life. But since we are not trying to recreate the entire world, mostly trying to recreate scenarios where we can play around remote presence or go to places where we couldn't go because it's too risky, not necessarily replacing. I saw some question related, and we can complement also that most of the non-VR display initiatives are more around haptic feedbacks and motion bases, because that's a very important topic, even though it's challenging and it's difficult to pull off as well. Providing feedback, haptic feedback, and movement matching could help with on the motion sickness and the different challenges that people face when you are moving into the virtual world, but your body is actually not moving in real life. So most of the initiatives we see are around that, essentially creating the sense of movement and trying to provide feedback in a way to minimize motion sickness and allow people to essentially experiment better, and also being able to spend more time on VR as well.
Very cool. And perhaps as the last question, I wonder if you guys could speculate with me to think about how many years out are we from the mass distribution of VR being used 100% in the workplace. This is imaginary. This is, what if? So go for it.
I do not have a good answer for that yet. For folks who are not familiar with it, a few years ago, there was kind of this resurgence of consumer VR with the Oculus Rift and so on, which was kind of fell out from the high resolution displays that you could get with phones. So essentially, some folks realized you could take those, attach some lenses, and create a half decent VR headset. So that kind of sparked a huge interest in it. And there was a lot of folks saying, well, look, within 5 years, we're all going to be in VR headsets and using them every day. I think, 5 years later, we're still not there. So it's very premature to make speculation about anything like this. My hope is that, someday soon, I would like to be doing a lot of my work in a VR headset. I don't know what day that will be, but for myself, I'm ready to start using this technology because I see so much hope for it. That said, I am in a research lab that looks 5, 10, 15 years out, so I can make very few guarantees about when this technology will really hit the streets.
So in terms of VR, we saw a growing adoption. So I think that we are in a good track, but as Ben mentioned, a few years ago, there were very optimistic views of how this could be applied. I think that a lot of people were looking at the entertainment industry as a way to really bootstrap. And it did in some point, but also I think that because of the cost of these experiences, because of the ecosystem, you need many devices, you need a lot of people using. So I think that we are in a good track. As Ben mentioned, it's very risky to say years and from now. I think that we are seeing more adoption on, and I think that we will see more adoption on areas like learning and some others, specifically for some industries that are looking into more interest. But as headsets become cheaper and more accessible and more ergonomics, obviously adoption will occur. It's not something that I think that we also misinterpret some years ago, is that we're really thinking that, again, gaming will push that and every gamer will essentially being able to and be an advocate of gaming, of VR, sorry. What we saw on the metrics that on the statistics we show at the beginning is that actually there's a lot of users that are not hardcore gamers. So we see some adoption, some companies like we pointed out, Walmart, some big retailers are looking into it. I think that right now they are starting to realize that even though they may have a fixed upfront cost to create these materials, over the long term, it makes more sense. So hopefully, as people also require more engaging experiences from the learning experience, they will push the companies to actually create more engaging experiences, whether that's VR or mixed reality. Obviously, that's all to be seen.
Great. Well, I think, unfortunately, we're out of time, although this conversation was fascinating. Thank you very much for your participation, Matthias. Thank you very much, Ben. It's been good talking with you.
All right. Thanks a lot, Anna.
Thanks to all our participants as well. Keep an eye out for upcoming Globant webinars, and you will receive a recording of this webinar in your email shortly. Thanks so much, all. Have a good day.
Thank you.
Bye.